In today's lesson titled Measure of Dispersion Quartiles, your objective is students will be able to calculate the quartiles of a data set and use them to develop something called a box plot. So at this point you should know that measures of dispersion are really measures of variability, how diverse our data set is. We learned about standard deviation and range in our previous lesson, and today we're moving on to something called a quartile. So the first thing we're going to learn how to do is how to sort our data into quartiles. And we're going to use the following data set, which is of Barney Circle, Potomac Avenue. These are 10 house prices that I found there. And what we want to do is we want to organize our data set by grouping it into different classes. Now these classes are very specific because quartiles are 4 classes of data, each containing 25% of the data. And this comes from the word quarter that is kind of embedded in this idea of quartiles. So we're going to break our data into 4 quarters. And in particular, what we want to find is we want to find our Q1, which is our first quartile, our Q2, which is our second quartile, and our Q3, which is our third quartile. And why are these pieces of information important? Well, Q1s are 25th percentile, meaning 25% of our data is below this value and 75% is above it. Q2 is really just our median, and this represents the middle of our data set. Half goes above and half is below. And then lastly, Q3 is the 75th percentile, so 25% of our data is going to be above this point and 75% is going to be below. So how can we find quartiles? Well, to find quartiles, the first thing you want to do is organize your data set from smallest to largest. This is an easy step. I've done it already over here. Smallest value at the top, largest value at the bottom. Next, we want to find the minimum and the maximum values. Now naturally, this is easy when your data set is already organized this way. The min's at the top and the max is at the bottom. The next thing we want to do is find the median value of our distribution. Now I'm going to repeat this process. You guys have learned this before, but to find the median value of a distribution, the easiest thing to do is just cross values out. So I'm going to cross the smallest and the biggest, then the next smallest, next biggest, next smallest, next biggest, next smallest, next biggest, and we're left with exactly 2 values in the middle. When we're left with 2 values in the middle, we want to find the average of the 2 by adding them together and dividing by 2. Once you've completed this process, we've now developed what will be our median, which is 400,000. That's directly in between 391,870 and 408,130. So we're done with the median. Once you find the median, now we can actually start finding our quartiles. And actually the median here is their second quartile, it's the 50th percentile. But now we want to find our Q1. And when you're finding Q1, all you're doing is finding the median of the lower half of our distribution. Now the lower half of our distribution is everything below our median. So these 5 data points right here. So what I'm going to want to do is I'm going to want to find the median of these 5 data points. So I'm going to cross out the smallest value and the biggest value, then the next smallest value and the next biggest value, and conveniently we're left with 1 data point remaining. So our Q1 is $362,400. Perfect. So that's our 25th percentile. That's our first quarter. To find the Q3, we do the exact same process, except we're going to do it with the upper half. So we're going to find the median value of the upper half of our data. Repeating this process, and you may be able to see a pattern here. If I cross out the smallest value and the biggest value, smallest value, biggest value, now we're left with this data point right here, and that right there is our Q3, or our 75th percentile. So we actually have calculated a lot of key metrics in this data set. So if we wanted to do a summary here, we call this a 5-number summary. Our minimum value, our Q1, our median value, our Q3, and our maximum value. That's a really good idea of what we're working with when we look at these housing prices. So now, moving from this information, we're actually going to build something called a box plot. Now, box plots are a perfect way for us to illustrate the quartiles. And you'll often hear this referred to as a box plot, or sometimes you'll hear it referred to as a box and whisker plot, and you're going to see when we develop this that it literally has a box and whiskers at the ends. So when developing a box plot, the first thing you do is you draw a line. And that line is going to represent our minimum value. This is the beginning of our data distribution, $262,000. The next thing we do is we draw a line extending from the min up to a box. Now the beginning of our box should represent our first quartile, Q1, which in this case was 362,000. And I want you to realize here that this space right here should represent 25% of our data. At the end of our box is Q3, and Q3 in our data set was $467,000. So now we know between Q1 and Q3 is the entire box of our box plot. Somewhere in the middle here, we should draw a line, and that line represents our median, which is also our Q2. Now you'll notice the median in this case is a little closer to our Q1 than it is to our Q3. There's a reason for that. It literally is closer to Q1 than Q3. 400,000 is closer to 362,000 than it is to 467,000. The last piece of our box plot is to draw a line extending away from our Q3 all the way to our maximum value, which is 514,000. This middle section is considered the box portion of our box plot, and these pieces right here are the whiskers. I do want to point out real quick so that we're understanding this clearly that the distance right here between the min and Q1, that should be 25% of our data set if we've done all the calculations correctly. And that is also the case for this distance right here. From our Q3 all the way to our max should also be 25% of our data set. Now, why are these box plots valuable? They sort of look goofy, but box plots allow us to evaluate relative standing. And that's where an observation falls within a data distribution. So if right now I went to Potomac Avenue and I looked at a house and I find out that that house was about $500,000, then I know immediately if I'm looking at a box plot of this data distribution that that house is very close to the max. It's going to be in our top quartile, well above Q3. It's the top 25% of our data. So relative standing is very valuable when you kind of want to figure out where a data point fits into the larger distribution. The next thing is it allows us to compare the variation of data distributions, and in particular the spread. And this term right here is a very huge term that we use in statistics. It's called the interquartile range. It's abbreviated as IQR. And what it really is representing is the middle 50% of our data between Q3 and Q1. It's also known as the box. So all you need to do to calculate the interquartile range is to look at your Q3 and subtract your Q1 from it. When I do this for this particular data set, I have 467K minus 362K. I'm left with 105K. This point right here is our interquartile range, and what it tells us is that the middle 50% of our data is about $105,000 wide, meaning between Q1 and Q3 we have a $105,000 spread. That's all you need to know today in regards to box plots and quartiles. Good luck on your assignment.